Hey everyone, my name is Anvita Bansal and we are back with another lecture based on linked list. So the question that we will be discussing today is detect loop in a Y-shaped linked list. Detect loop in a linked list basically. I'll just show you the question. So this is your linked list, not need to be Y-shaped. Okay, so let's understand the problem first. You are given a linked list of n nodes. Your task is to check if the linked list has a loop. Linked list can contain self loop. So let's understand how they have given us this problem statement. So if you see n is equal to 3, which tells you that total number of nodes in a linked list, then they have given you x, which tells you the position at which the loop is found. If you find a loop, you are going to return a true, otherwise false. Now how it is representing where the loop is? So x is 2, which means at second position, the last node is connected to the second position in order to form the loop. So how is it going to look like? I'll show you. And if you see the second test case as well, here x equal to 0. So positioning is starting from position 1, 2, 3 and 4 and so on. When x equal to 0, that means there is no loop found here. Last node is pointing to null itself. Okay. So let's understand this 1, 3, 4. Let me just show you. So for example, you are given 1 is pointing to 3, it is pointing to 4, and x given to you is 2, which means what is second position? This is position first, this is position 2, and this is position third. So the last node is actually pointing to your second node, that is x equal to 2, in order to form a loop. So it is going to look something like this. 1 is pointing to 3, 3 is pointing to, let me write it like this, 3 is pointing to 4 and 4 is pointing back to 3. So do you see that there is a loop which is found at this position? Okay. Now your task is to detect if there is a loop present in a linked list. So let's take a bigger example. For example, I have 1 pointing to 2, 3, 4, 5, let's say 6, let's say. Then it is probably pointing to 7 and 7 is pointing to 2. For example, this is your linked list. Now you can observe that the node at which the loop is found is this node, right? This is the node at which loop is found. You don't need to return the position. You just need to return true if the loop is found and false if there is no loop found. So see, how can you do this problem? In this problem, you can either visit each of these nodes, mark them, or maybe use a data structure like hash map, in which you can keep the track of which nodes have been visited, and as you traverse, when you reach at that visited node once again, that means there is a loop found at that particular node. There's this one way, but we can do one more thing in which we don't even need to use any hash map or any other data structure, any extra space, which is typically your Floyd's cycle finding algorithm. So it is just based on this intuition. See, the intuition behind this algorithm is that you are going to have two pointers. One pointer will be moving faster than the other pointer. Now what does this mean? Just take an example. For example, you have a path like this. Okay, wait. Just assume that this is some path. This is a lap on which there are two cars going to run over this track. Okay, one is moving at the speed of 1x, other one will be moving at the speed of 2x. If these were two separate paths, okay, right? So car which is moving at 1x will be moving at the constant speed. Other one moving at 2x will always be ahead of the car that is moving at 1x. So if it was a linear track, you would never be able to chase the car which is moving at 2x speed. Got it? So there are two cars moving on the same road, starting from the same point, but since one car is moving at twice the speed of the other car, you will never be able to chase it. But now just imagine it as a path like this. Okay, so if you have a path like this, a circular path probably, So in this path, no matter you started till the time you were linearly moving, you will not be able to chase. But once you are on the circular track, okay, I'm just trying to help you understand it in layman terms so that you can understand the intuition behind this algorithm. Now once you are moving on this track which is circular, so even if the car which is moving at 2x, it will find there will be a spot when the car which is moving at a slower speed will be able to catch it. The reason behind is, let's say at some point in time, let me take it like this, there are nodes on this track. For example, I am taking this track having some nodes here, 1 2 3 4. For example, the moment my car 2 C2 is, let's say, at this position, C1 is at this position, at any moment C2 will move, let's say, 2 points, that is 2 x's at a time. So when C1 was here, C2 was here, in the next lap, for example, in the next moment, C2 will be found at x next to the previous x. That means it will skip 2 x's and come at this position. So C2 will be found here and C1 will just move by speed of 1x. So C1 can be found here. Now in the next step, C2 will move 2x, okay. So C2 will come here, but C1 will go here. In the next lap, C2 which was present here, it will come here, and C1 which was present here, it will come here. So there will be a point, no matter after how many laps, they are going to collide, right? So that is the entire intuition behind this. Now let's come back to our original problem. So how are we going to do this? We are going to take 2 pointers. One is slow pointer and other one is fast pointer. Both are initially pointing to head, okay. Now move your slow pointer by speed of 1. That means slow will move to the next pointer in every iteration, fast will move to the next pointer in the every iteration. So in the next iteration, slow comes here, fast comes here. Next iteration, slow comes here, fast goes 1 2 this at this node. In the next iteration, slow comes here and fast goes at 7, right? In the next iteration, slow comes at 5, node 5, and fast goes at 2 3, comes at this. Now in the next iteration, slow comes here and fast comes at 4 5, right? In the next iteration, slow points at 7 and fast is also pointing at 7, right? Fast is also pointing at 7. Now the moment that these two are pointing to the same node tells me that there was a cycle in this linked list. Because if it was a linear path, that means it was a linear linked list, singly linked list, it is a singly linked list, but if it was in linear fashion, there was no chance that slow and fast pointer would have collided with each other. But since I found a circular track, that is the reason that slow and fast pointer got to collide with each other, and there was a moment that they were pointing to the same node at some point in time, right? So you are going to move your slow and fast pointer until one of them is pointing to null, okay. And also, for example, if it was a linear data structure 1 2 3 like this, okay, slow is pointing here, fast is pointing here. In the next iteration, fast will directly come here, slow will come at this pointer. Now in the next iteration, fast will try to go to 3 dot next, means this node's next dot next, but that is an invalid node because 3's next is null. So you have to make sure that fast dot next is not null, okay, along with slow and fast should also not be null. So this is an extra check that you need to put because fast is moving by 2 pointers, right? And you have to make sure that when it tries to go to dot next, you need to make sure that it is not present at the last node, okay. So for that we are going to add this extra check, okay. So I hope you understood this problem. So it is nothing, we are going to use a while loop which runs until your slow is null, your fast is null, and your fast dot next is also not null, not null, okay. Until then you are making your slow pointer move by 1 pointer every time. Slow equals slow dot next, fast will be fast dot next. if your slow pointer, the pointers should be same, means these two pointers should be pointing to the same node. If slow becomes equal to fast, you simply return true. Otherwise, you come out of the loop and return false. Fine. So how much time are we taking for this? At max, so since there are the n number of nodes, at any point in time they will collide. So typically you can say it is taking O(n) of time complexity. We are moving at these nodes. Okay. So no extra space. Let's go and code it. So let's just node fast, node slow equal null, not null, head, pointing to head. Node fast also pointing to head. I'll just check if you guys were able to see my screen. Yes, I think. Thank you, Ashish, for. Okay. So while your slow is not equal to null and your fast is not equal to null, also you are checking that fast dot next is also not equal to null. What are you going to do? You are making your slow move to slow dot next, fast move to fast dot next. Okay, if they happen to meet at the same node, slow is equal to fast, that means there is a loop detected, return true. This was a simple question only. Okay, and otherwise you come out of the loop, return false. Okay, that is all about it. So I hope you understood the problem. If you have any doubts, you can ask me. I hope I was audible without any echo. Fine. Then that was all for today, guys. If you have no doubts, I will wrap it up. Okay, then. See you all in the next lecture, that is tomorrow. Till then, keep coding. Bye bye and take care.